All right, is everybody ready? Hello guys, my name is Aaron Hall.
And I'm Michael Roznik.
And our senior design project this semester was to design an expandable brush. So let's go ahead and look at the market need and analyze this. So it's very difficult to clean vessels with small necks, large, wide bases, or complex geometries. Take, for instance, this wine decanter. If you can consume an entire wine decanter, you're very unlikely to be able to clean that wine decanter out that same night. Consequently, you end up with a very sticky residue on the bottom that's very difficult to clean. Unfortunately, there's really no universal means for us to clean this out. You can see sometimes rice is used, ball bearings, or ineffective and awkward wire brushes. So our senior design project was to address this need in the market so that we can just put a brush in, expand it, and clean our decanter. So we really took a product development approach to this project. We wanted an effective and quick operation. We wanted a simple design that was easy and cheap to manufacture and could be done completely with 3D printing facilities here at Washington University. We wanted it to be conveniently operated while also maintaining safe use since it will be used in a domestic setting. The design constraints that we chose to evaluate our project was this specific wine decanter. We wanted to be able to clean it completely. In addition to that, we had to have our brush be reusable and versatile, not just for this geometry, but for wider or more narrow types of vessels.
So for our design, we were evaluating 3 different types, and what we ended up choosing is an outer sleeve with a deflector and a separate piece that holds a bunch of bristles that can be adjusted to splay out at different radii. So for this design, the 2 things we had to focus on were first the bristle materials. So we needed something that was going to be stiff enough that when fully expanded, it would still maintain like a perpendicular direction to be able to clean the vessel. We also needed to work with a 3D printing. So we wanted to minimize our design to make it as versatile as possible. But at the same time, we had to deal with print resolution to make sure that we could print accurately and keep our constraints. So this is our risk heat map. I can go over this more during the questions time if you like, but the main takeaway here is just that this was very accurate for us. So for our prototype, we used 3 5-inch sections for our outer tube. And the reason we did this is because the maximum height of the 3D printer we used was 6 inches. From there, we attached the deflector, which was also 3D printed, and we ended up using nylon broom filaments for our bristles in our prototype. So Aaron is now going to pull up our prototype video, cleaning the wine decanter.
Can you tell us what's in the wine decanter that you're cleaning?
Yeah, so in here we just added some random sediment and particles we found in the shop, the senior design shop. But as you can see here, when the brush is fully inserted, it easily reaches the outer edge of the decanter. We actually measured that the maximum radius that we could reach with this prototype was 9.5 to 10 inches. And then here, the brush is changed so it can actually clean a lower lip that's also part of the decanter. One thing we had issues with this cleaning was getting the upper surface as clean as we would have liked. So we have some ways to improve that, which I'll go over after this video. But the thing here is just that the brush is versatile enough to reach different portions of the geometry, and when we're finished cleaning, the bristles are easily retracted and the brush can be removed from the vessel. So now for our improvement and next steps. The first thing is we want to decrease the diameter of our outer tube. This would allow us to tilt the brush more once inside the vessel, which will make it easier to reach some of those places. We also redesigned the deflector, and our most promising is the one on the far left, which has half the same as our last deflector, but half the area actually pushes the bristles upward, so we have 2 different angles to reach the vessel. We also want to increase filament stiffness and density, just so we have more bristles per area for cleaning. And the last design we're considering is adding a sponge or Brillo pad type material to the bottom of the deflector to allow users to clean the base of the vessels more easily. So at this time, we'll open it up to any questions you may have.